From the dawn of humanity, we have gazed up at the stars and wondered about our place in the cosmos. This curiosity has driven us to explore the unknown, pushing the boundaries of knowledge and technology. We have landed on the moon, sent probes to distant planets, and even glimpsed the edge of our solar system. But these incredible feats require immense amounts of energy. As we venture farther into space, we need sustainable ways to power our spacecraft. This is where the sun, our nearest star, comes in. For millennia, humans have relied on the sun for warmth and light. Now we are harnessing its energy to power our most ambitious space missions. Solar energy, a clean and abundant resource, is proving to be a game changer in space exploration. It allows us to explore the cosmos without relying solely on finite fuels from Earth. In this essay, we will delve into the world of solar-powered space travel. We will explore how this technology works, its applications in current missions, and its exciting potential for the future of space exploration. The sun, a giant ball of hot gas, constantly releases energy in the form of light and heat. This energy, known as solar radiation, is the driving force behind life on Earth. It also holds the key to powering our journeys through space. Solar energy is harnessed using solar panels, which are made up of photovoltaic cells. These cells are designed to capture sunlight and convert it directly into electricity. Think of a photovoltaic cell like a sandwich with special ingredients. When sunlight hits this sandwich, it knocks loose electrons, creating an electrical current. This process, known as the photovoltaic effect, is the basis of solar power. On Earth, we use solar panels to power homes, businesses, and even entire cities. In space, solar panels serve a similar purpose, providing a constant and reliable source of energy for our spacecraft. Solar power has become an indispensable part of space exploration. Many of our most successful missions, from the Mars rovers to the Juno spacecraft orbiting Jupiter, rely on solar energy. The Mars rovers, Spirit, Opportunity, and Curiosity are prime examples of solar-powered exploration. These robotic explorers, equipped with large solar panels, have traversed the Martian surface for years, sending back invaluable data about our planetary neighbor. The Juno spacecraft, currently orbiting Jupiter, faces a unique challenge. Jupiter receives significantly less sunlight than Earth or Mars. To overcome this, Juno is equipped with 3 massive solar arrays, the largest ever used on an interplanetary spacecraft. These arrays, spanning over 60 feet, provide enough power for Juno to study Jupiter's atmosphere, magnetic field, and internal structure.
Section 4. Challenges in the darkness. Keeping the lights on. While solar energy is a powerful tool for space exploration, it also presents unique challenges. As we venture farther from the sun, sunlight becomes weaker, requiring larger and more efficient solar panels. Spacecraft exploring the outer solar system often encounter extreme cold and darkness, further limiting solar power generation. However, scientists and engineers are constantly innovating to overcome these challenges. One solution is to develop more efficient solar cells that can generate more power from less sunlight. Another approach is to use radioisotope thermoelectric generators, or RTGs, in conjunction with solar panels. RTGs produce electricity from the natural decay of radioactive isotopes, providing a reliable power source even in the absence of sunlight. These innovations are crucial for extending the reach of solar-powered space exploration to the farthest corners of our solar system.
Section 5. Solar sails, riding the waves of sunlight. Imagine a spacecraft propelled not by rockets or engines, but by the gentle pressure of sunlight itself. This is the concept behind solar sails, a revolutionary technology that could transform space travel. Solar sails are large reflective sheets that capture the momentum of photons from the sun, propelling the spacecraft forward. Think of a sailboat catching the wind, but instead of wind, we are using the constant stream of photons from the sun. Solar sails offer several advantages over traditional propulsion systems. They require no propellant, eliminating the need to carry heavy fuel tanks. They can provide continuous acceleration, potentially enabling spacecraft to reach incredible speeds over time. While still in its early stages, solar sail technology holds immense promise for future space missions, including interstellar travel.
Section 6. A bright future. Solar energy and the final frontier. As we continue to explore the cosmos, solar energy will undoubtedly play a pivotal role in powering our journeys. From the Mars rovers to the Juno spacecraft, solar power has already proven its worth in space exploration. Ongoing innovations in solar panel technology and the development of solar sails are opening up new frontiers, allowing us to venture farther and explore more efficiently than ever before. The future of solar-powered space exploration is bright. As we strive to become a truly spacefaring species, harnessing the power of the sun will be crucial to our success. It will enable us to establish a sustainable presence in space, unlock the secrets of the universe, and perhaps one day, reach for the stars, powered by the very same energy that sustains life on our own planet.